Today we're going to talk about inverse variation. So we know that when two variables vary directly, when one increases, the other increases, and when one decreases, the other decreases. So these equations that are direct variation look like y equals a times x. When y goes up, x goes up. When y goes down, x goes down. A, the a value, is called our constant of variation. Smartboard's being a little squirrely. All right. So an example of that is if you bought a gallon of milk, it cost $2 to buy 1 gallon. So if you wanted to buy 10 gallons, that price would obviously increase. So as the number of gallons you purchased increased, the price increased. But today we're going to talk about inverse variation. And this is when one variable increases, the other one decreases. And so that looks like this, y equals a divided by x. And this makes sense because as x, our number in the denominator, gets larger and larger, our y value is going to get smaller and smaller. An example of this would be if a biker was traveling at 8 miles an hour, he would go 8 miles an hour. However, if he decreased his speed, the time it would take would increase. So that's inverse variation. Once again, our a is still called a constant of variation. So now we're asked to classify the equations as direct variation, inverse variation, or neither. Now this first one might seem tricky, but remember we need to write our equations in the form y equals something. So in order to get y by itself, we have to divide both sides by x. So we get y equals 1 divided by x. Now we can tell from this that this is similar to our inverse variation form. And so we know this is inverse variation. Our constant of variation in this instance would just be 1. Now we look at this second one. A lot of people want to say direct variation because as x goes up, y goes up. However, this is neither. Remember that our direct variation looks like y equals a times x. That's not what this is. Our direct variation will always go through the origin. This does not. Alright, this last one, a lot of people see the division sign and assume inverse, but notice this can be written as y equals 1/7 times x. This is an example of direct variation, and 1/7 is our constant of variation. Now we're going to look at a table of values in order to decide if it's inverse variation, direct variation, or neither. So now remember, with direct variation, y equals a times x. Now we notice if we divide both sides by x, y divided by x gives us our constant a. So if we were to take our table of values and do y divided by x, if we were to get the same number, our same constant of variation, we would know that this was direct variation. So let's try that really fast. So let's start with our first set. If we do negative 12 divided by 2, y divided by x, we get negative 6. Now if we look at our second set and we do negative 6 divided by 4, we get negative 3/2. Since we did not get the same number when we did y divided by x, we know that this is not direct variation. How do we determine if it's inverse variation? Well, we know inverse variation is y equals a over x. So if we multiply both sides by x, x times y should give us a constant of variation. That means for every x times y, we should get the same number. So if we try that, we do 2 times negative 12, we get negative 24. If we do 4 times negative 6, we get negative 24. A lot of people want to stop here, but you need to check every single value. We do 6 times negative 4, we get negative 24, and we do 8 times negative 3, we get negative 24. So now we know, because x times y equals a constant of variation, a, we know that this must be inverse variation. and our constant of variation would be negative 24. Same thing over here. We can check first to see if it's direct. If it's direct, y divided by x is going to give us a constant a. So if we do y divided by x, 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 3 is 8/3. Once again, this is why we have to keep checking. So now we know it's not direct. So let's check to see if it's inverse. Remember, if it's inverse, y times x equals our constant a. If we do y times x, we get 2 times 1, we get 2. 4 times 2, we get 8. We know already that it is not inverse, which means it has to be neither. Now this asks us to write our own equation relating x and y. So it tells us the variables x and y are vary inversely. So we should automatically think of our inverse variation equation, y equals a divided by x. And x equals 4 when y equals 8. So we can plug in 8 for y and 4 for x. It asks us to use these given values to write an equation. So what we're going to do now is we're going to solve for a. So we're going to multiply both sides by 4. And we know that a equals 32. So now we can write our equation as y equals 32, our constant of variation, over x. It then asks us to find y when x equals negative 16. All we have to do is plug negative 16 in for x, and y equals negative 2. We're going to do the same thing on this one. It tells us that the variables x and y vary inversely, and x equals 5/3 when y equals negative 7. So remember, if it's inverse, it's y equals a divided by x. So we know negative 7 equals a divided by 5/3. So we're going to multiply both sides by 5/3. Which means we get a equals negative 35/3. So we're going to substitute that back in. So y equals negative 35/3 over a. Sorry, over x. But we don't want a fraction in a fraction because that's atrocious. So we remember that dividing by a number is the same as multiplying by its reciprocal. So this is the same as y equals negative 35 over 3 times, this is still an x, times 1 over x. Or, so y equals negative 35 over 3x. When we plug in 3 for x, we get y equals negative 35 over 3 times 3, which is 9. Last one is a word problem. The time t in hours it takes a group of workers to roof a house varies inversely with the number of n workers. If it takes a group of 4 workers 9 hours to roof a house, make a table showing the time it would take to roof a house when the number of workers is 2, 6, 9, and 12. So, we make our table. We have n is the number of workers and t is our time. If it helps, n is our x variable and t is our y. And it asks us to find when n equals 2, 6, 9, and 12. So here's our table. Okay, in order to find our y values though, first we're going to need to figure out what our equation would be. Since they give us 4 workers take 9 hours, we can use that information. So we know this is going to vary inversely because the more workers you have, the less time it's going to take. So y equals a over x. We know that it takes 9 hours for 4 workers, and so we can solve this by multiplying by 4. And so we know our constant of variation is 36. So our equation is y equals 36 divided by x. Or, even more properly in this, t equals 36 divided by n. So, we're going to use this to find our values for this table. So, if our n is 2, 36 divided by 2 is 18. If our n is 6, 36 divided by 6 is 6. For n is 9, 36 divided by 9 is 4. And for n is 12, 36 divided by 12 is 3. And so that's our table of values. So we can see as the number of workers increases, 2, 6, 9, 12, the number of hours it takes them decreases, which makes sense because this is inverse variation.